Everyone, today I will present our mini project for NMJ41203 image processing. Our title is Fingerprint Recognition System using image compression, Gaussian blur filter and morphological operation which include opening, closing, erosion and dilation. Let me introduce our group members, which consists of two. One is me, Sian Feng 211022082, and my beloved friends, which is Najihah, Afiqah, Binti, Norsham. Her metric number is 2210222251. Next, let's go through for introduction for our mini project. The fingerprint recognition is a widely used biometric authentication method due to its uniqueness, reliability, and ease of use. Fingerprint provides a secure and convenient way to verify identity, unlike password or pins. The common application for the fingerprint recognition is in law enforcement, mobile devices, banking, and access control system. So, in this literature review, aim to explore the evolution, challenges, and future trends in fingerprint recognition system by analyzing key research findings. It discusses various fingerprint recognition techniques, providing insight into that improve the reliability and robustness of these systems. There are three problem statements we could find in this project. First, role of fingerprint recognition system. Second, challenges in traditional methods, and the third one is importance of pre-processing techniques. Role of fingerprint recognition is crucial for biometric authentication, and the accuracy affected by pure image quality, noise, and artifacts. The challenges in traditional methods, which is struggle with illumination, variation, and background noise. Incomplete or fingerprint capture lead to false acceptance or rejection. Next, the importance of the pre-processing techniques. Enhance fingerprint image before feature extraction. We will use morphological operations such as opening, closing, to remove the noise while preserving the structures, while erosion and dilation is to refine ridges, detail, and connectivities. So, our objective for this project is to improve fingerprint segmentation using binarization by implementing binary thresholding to distinguish fingerprint ridges from the background. Second, to refine the fingerprint images through morphological operation by utilizing opening and closing operation to remove small noise and fill gaps in the ridge. The third one is to enhance ridge details for accurate features extraction by applying erosion and dilation techniques to highlight essential ridges patterns while eliminating unwanted artifacts. Now I will present the literature review for the project. First, image enhancement and noise reduction. For image enhancement, there are three methods, which is grayscale conversion, Gabor filtering, and Gaussian blurring. For grayscale conversion, simplify processing while retaining ridges details. For Gabor filtering, the uses is to enhance ridge orientation and reduce background noise. And lastly, for Gaussian blurring, it is used to preserve ridges while reducing minor noise. For noise reduction, we have two methods, which is median filtering and diffusion filtering. Median filtering is to eliminate salt and pepper noise, while diffusion filtering is to maintain the ridges structures while reducing noise. The second literature review is binarization and segmentation. It is used to simplify image processing for faster and more efficient analysis. Second, to enhance ridges clarity by adding in miniature abstraction. Lastly, it is to reduce noise and background artifacts so that it can improve the identification accuracy. Lastly, in literature review, we talk about morphological operation for ridge enhancement, which is dilation operation, erosion, opening, and closing operation. This is an example of dilation operation. Dilation expands the ridges in a fingerprint image by adding pixels to the boundaries of objects and help to connect broken ridges to enhance the visibility of the image. Dilation can strengthen ridge structure by filling gaps in broken or fan ridge line to improve the continuity of ridges and make feature extraction more accurate. This is the 3x3 structuring elements used most in the morphological operation, which is dilation, erosion, closing, and opening. So if there is larger structuring elements used in the process, the extreme effect of the operation may occur. So next, we will see erosion operation. Erosion shrink ridge by removing pixels from their edges, which cause the thinning ridges. This is helped to remove the small noise and unnecessary details that might interfere with recognition. By using the same 3x3 structuring elements, the effect we'll get for this operation is this. So next is opening operation. Opening is a combination of erosion followed by dilation, which is erosion removes small noise such as small white patches that should not be part of the fingerprint, and the dilation restores the main ridge structures to ensure no essential details are lost. Lastly, I will talk about closing operation. Closing operation is a combination of dilation followed by erosion. Dilation fills small gaps and holes in the ridge structure, and erosion will restore the fingerprint ridge to their natural thickness to enhance the continuity of ridge lines and make sure no gap exists. With this understanding, our project implements a structured pre-processing pipeline integrating these techniques to enhance fingerprint clarity and recognition accuracy. In the next section, I will pass to my friend to discuss our methodology and implementation, and also result and discussion.
Assalamualaikum warahmatullahi wabarakatuh. My name is Najihah Binti Norsham. My meeting number is 221022251. So I will continue explaining the system program code and how the program will generate result to recognize the fingerprint that already stored in the system with the input fingerprint. So this program is code in Python, where we also import OpenCV libraries to use for image processing, including writing, reading and applying transformations like filtering and morphological operations. And then we use NumPy libraries to handle numerical operations to calculate the similarity. And then we import the OS for handling the file path, to creating the directories to store the image in a folder. And then we use PIL, which is referred to pillow. That is, pillow image is used for format conversions, resizing the image, compress the image, and save and load the image in different formats. And then we import the I/O libraries to help in saving image to a buffer before reloading them into OpenCV to be processed. So our code is programmed by initialize and load the data collection, which is initialize the data collection that will be stored, which is in fingerprint dataset real, where in this folder there is about 50 dataset, where it consists of 5 people fingerprints, where each of the people have 10 fingerprints that have their little fingers, ring fingers, middle fingers, index fingers, thumb fingers from the left to the right, and makes the total of all these 5 peoples have 50 data set of fingerprints. So after that, we load the fingerprints into the system, and then we do process collection, where in this function the image is read in grayscale, do the image compression, and then we apply the Gaussian blur for filtering the noise, and then we convert to binary to make it purely black and white image, and then we do morphological operation to fingerprint enhancement. And then this is for definition for compress the image, and this is for applying the morphological operation. So in morphological operation, we do the opening operation, closing operation, and erosion. And then we have function for save each of the stage that has been generated from original to compress and blur, binary, open, close, and final step. And then after have saved the process stage, we compute the similarity by calculate the pixel similarity, and then the structural similarity of the input and data collection. And then we do find the match fingerprint by sort the highest similarity to the lowest similarity. So here the last one is the main function, where we code to generate and perform all the function that we written above, and initialize which input we need to process. So now I will explain to you and demonstrate how to run this code and obtain the result. First, we open the terminal. Since this code file is code in Python, so we use Python, and then referring to this code file, fingerprint recognition system.py. So we enter. So as you can see, the dataset now is successfully loaded into the system, and then undergoes for image processing, where it include image compression, applying the Gaussian blur, convert the image to the binary, and enhance it using morphological operation. And then it process and analyze the input fingerprint, same process, where it compress and go to the Gaussian blur, and then undergo for binary, go for opening, closing operation, and as you can see, it will save each of the process into the process stage directory. So in the process stage folder, you can see there is 7 input image that have been processed. So here is the result of the image. As you can see, the left is the original input image, where it is the starting point of the grayscale fingerprint image, input fingerprint 2 that loaded, and then it go for compress. So the file size is now has been compressed to the smaller size, which is 85% to the original. And then it go for blurring operation, where it applies Gaussian blur to smoothing and reducing the noise. And then the input fingerprint go for binary operation, which as you can see, it converts from the grayscale image to the black and white. So in this binary image, we can see it is clearly spread the line and then the reach of the fingerprint pattern, and it enhance the contrast for feature extraction. And then we can see after opening operation, we can see that combination of erosion followed by dilation remove the noise particles and smooth the object contours by maintaining overall rich structure, and make the lines more continuously than before. And then the morphological operation do the closing to the input fingerprint. The closing is the combination of dilation followed by erosion. So in this step, it fills small holes in the ridge, whereas you can see the gaps and holes of the fingerprint now is filled and connects nearby to each other. And then lastly, erosion alone. So in the erosion step, it makes highlight the core fingerprint patterns and optimize the fingerprint lines for detection. So after that, the input and data collection will be performed the similarity matching by calculating the similarity calculation, where it will calculate the pixel similarity and structural similarity of the image, combining those two calculations, and then sort it by the highest to the lowest, and makes the highest one is the best match of the fingerprint, which is 5M left index finger .bmp image with similarity score 1, which is the most similar fingerprint with the input fingerprint 2. So how we know that this program compute or obtain the best match result in recognition which the input fingerprint is referred to is right or not, or perform well or not? So we actually do take note that the original image, fingerprint image that we use as input is referred to what. So we have take note that input 2 is referred to 5M left index figure. So here in the result, we can see that 5M left index figure is obtained as the best match similarity result to the input fingerprint 2. So it is same here, make the result of the output is correct. So that's all from me. Thank you.
To conclude this, our mini project main is to develop a fingerprint recognition system integrating pre-processing and similarity comparison for improved feature extraction and noise reduction. We use compression, Gaussian blur, binarization, and morphological operation. The morphological operation we use is opening, closing, erosion, and dilation. Opening is used to remove noise, while closing is to fill the gaps. Erosion is thin ridges for better analysis, while dilation is to thicken the ridges by adding pixels to the edges to enhance connectivity. So, for this project, we achieved the similarity score. Highest one is 1.000, which is perfect match, and confirming the system reliable. That's all from us. Thank you for watching our videos.